In this presentation, we are going to look at how to calculate the eigenvalues of this matrix A. So A here is 3 by 3 matrix. Okay. Now, the way we're going to calculate it is that we are going to use this equation here called the characteristic equation. Now, I'm just using this form here, but actually if you want to sort of use a slightly different form of it, that's perfectly equivalent to, you get the same answer. So this is the characteristic equation. The other form of it is that you have, what I have here is A minus lambda I. I is the identity matrix and lambda is a scalar value. And we compute that and get the determinant of it. Now some books you might have lambda I minus A, get the determinant of that. They work out the same way, so it doesn't really matter so much. So let's go to my next slide here, my next page, and let's have a look at that. So what we're particularly interested in now is, here we have it there, A, there's A, and that is lambda I. So here we have A. The identity matrix is, this is simply lambda multiplied by the identity matrix, and the identity matrix is 1 0 0 0 1 0 0 0 1, and we just multiply each term by lambda, so we get this over here. So when we subtract A minus lambda I, we get that, this matrix here. Now what we are looking for is the determinant of that matrix. That gives us the characteristic equation. We let that equal 0 and then solve for lambda. So we should get 3 solutions for lambda. So what I'm going to do here, if first off, very importantly, we are going to use the cofactor, the method of minors, for finding the determinant. And what we're going to do here is we're going to use the top row, because we have 2 zeros here. Now if you're unfamiliar with how to compute the determinant of a 3 by 3 matrix, just stop this video now and go look at that instead. So let's compute this now, the determinant of this matrix here. And let's just scroll down a bit so we're looking at that in particular. So we have the top row, and so the first item in the top row is 1 minus lambda, and its minor matrix is this part here. Now I'm going to highlight it in because it's the only part of the only minor matrix we're actually going to use. So the determinant of that, 1 minus lambda 4 1 minus lambda. So this is in the sign array position. We'd have a minus 0 here, and we get the determinant of its minor matrix. That will be these 2 values here and these 2 values here. But because it's 0, we're going to disregard that. Likewise, the last 0 there, we're going to just disregard it because they're 0 and they're not going to contribute to anything. But just so you've formally, so what I have here in this between the bars here, just to sort of left it out, these are the minors, the minor matrices for the 0 and 0. But because 0 and 0 are zeros, they're going to just cancel out immediately. So we're just going to sort of disregard them and use this first component only. So let's just work that out a bit further. So what we're going to do here is get the determinant of the minor. So it's lambda. So 1 minus lambda. Okay. Now it's 1 minus lambda times 1 minus lambda minus 4 times 4. Essentially what we've done there is we've got the matrix, the determinant of this 2 by 2 matrix. Okay, so let's work that out a little bit more. Scroll down. And what do we get? So that's 1 minus lambda by 1 plus 2 lambda minus 2 lambda, reading from the wrong page, plus lambda squared. And minus 16. So to cut a long story short, what we have here is one minus lambda. We're just going to leave that out permanently. Lambda squared minus 2 times lambda, and we have 1 there and a minus, so minus 15. So we just have to factorize that, and we make that lambda plus 3 lambda minus 5, and also 1 minus lambda down here. Okay, so this here is as good as we're going to get with regards to the characteristic equation. 1 minus lambda, lambda plus 3, lambda minus 5. So essentially, if you recall, that we have to let the characteristic equation, we have to solve it, we let it equal 0. Okay, so essentially each of those 3 terms, so lambda equal to 1, that would make it 0, disregarding all the other values. Lambda minus 3, sorry, let's say lambda equals minus 3, and lambda equal to 5. Okay, so 1, the eigenvalues are in order, let's write them here like this: minus 3, 1, and 5. Okay, and those are the eigenvalues which we denote with lambda. Alright, that ends this presentation. Now there's a good bit more to do after this, but this is a good time to stop.